Have you ever wondered how data is organized in a computer system? Well, the answer lies in the realm of data structures. These ingenious systems allow data to be stored, retrieved, and manipulated efficiently. Today, we will delve into four common data structures: arrays, linked lists, stacks, and queues. Firstly, consider arrays. An array is a collection of items stored at contiguous memory locations. The items could be integers, strings, floating point numbers, or any other types of data. Arrays are the simplest data structures, and they are the foundation for more complex structures. Imagine a row of lockers, each holding a different item. That's an array in the simplest terms. They are particularly useful when you need to access elements by their index, or when you know the specific position of the data you're looking for. Next up, we have linked lists. A linked list is a linear data structure where each element is a separate object. Each element, or node, holds a reference to the next node, creating a chain-like structure. Picture a scavenger hunt where each clue points to the next. It's a dynamic data structure, meaning it can grow and shrink at runtime. Linked lists are great when you need to add or remove elements frequently, as they can do so without shifting other elements around. Moving on to stacks. A stack is a linear data structure that follows a particular order in which operations are performed. The order can be LIFO, last in first out, or FILO, first in last out. Think of a stack of books. You can only add or remove a book from the top of the stack. Stacks come in handy when you need to reverse a word, check for balanced parentheses, or in backtracking algorithms. Finally, we explore queues. A queue is a linear data structure that follows a particular order in which operations are performed, specifically FIFO, first in first out. This means the first element inserted will be the first one to be removed. Imagine a line, the movie theater. The first person in line is the first to buy a ticket. Queues are commonly used in breadth-first search algorithms and for handling requests in shared resources like a printer. To summarize, data structures are the backbone of any computer system's data organization. Arrays provide simple index-based storage for fast access. Linked lists offer dynamic, efficient insertion and deletion. Stacks utilize LIFO or FILO operations for tasks like word reversal and parenthesis checking. Lastly, queues employ a FIFO method, perfect for handling tasks in the order they arrive. In the world of computer science, understanding these data structures equips you with the knowledge to design and implement efficient algorithms. It's like knowing which kitchen tool to use for a specific task. With this knowledge, you're one step closer to mastering the art of programming.